It's about to start. We'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause this stream is about to start. Get ready wherever you are, 'cause this stream is about to start. Hello everyone and welcome. Haha, surprise! You thought we were gonna be doing this at 1, but we are doing this at 12. Hello David, how are you doing?
From yesterday, and thank you for doing it a little bit earlier. It's much appreciated.
Of course. So let's continue from where we left off, and that is... I should put you back on the screen now that the camera is working again. There.
And share your screen, please.
Yes. Okay, so we were in part 2 of day 14. And
yes,
I just want to quickly share the idea that I have. I
Sure.
explored a little bit of the regular expression thing, and perhaps there is a clever way of doing it. But here is a way to do this without regular expressions, and it's easy enough. So suppose that you have a line that is one of these guys, and that you want to propagate all the rocks to the left. So for instance, this rock would come here. Here's how you do it. Do whatever. The structure here doesn't matter. What you're gonna do is just do something that amounts to line dot replace all. I think that's the thing in JavaScript. Any of these into one of those while it hasn't settled yet. It hasn't settled yet. So while you're still making changes to the line, keep doing this, and this way the rocks will all go to the left. See what I mean?
That's beautiful. Yeah, that's really nice. That's very, very nice. And it's also like, if you were to animate it, it would be like slowly moving things as well. Be doing one thing at a time. Really cool
that's
to
the
see.
way to do it. Yeah, right. Okay. So we are now trying to do the cycles, 1 billion of them.
So there are 1 billion cycles. Where we left off yesterday was we will actually do the cycles, detect a cycle in the cycles, and then extrapolate where the board will be. And we're just hoping that's going to work.
Really? Ooh, wow. Okay. My idea was a bit perhaps simpler. It was to just execute the cycles, but try and memorize and see if we get lucky again.
Yeah, that was... Oh, I see. Well, that was kind of the idea, but memorize would be
Because
because then we could still execute. We wouldn't have to work out like the index or anything.
yeah, if we are lucky, I mean, the problem, it can be solved one line or one column at a time. It depends on how you want to think about it. But each column is independent. So there is the problem of the rotation, and there is the problem of moving the rocks. Moving the rocks, I am fairly certain that if we memorize, we will find patterns pretty quickly and use the cache a lot. Great. For the rotation, maybe if the problem is structured well enough, we could even memorize the rotation, all of the rotation, in another, of course, in another cache. See what I mean? So the whole input would be the key, and the whole output would be the value in that cache.
Yeah.
And then for each line, we would have a separate cache, which is just the input being, for instance, this line, and the output being the line with the rock all the way here, for instance.
Yeah, that's definitely true. Well, regardless of where we memorize or whether we detect cycles in the cycles, we need to implement north, south, east, west, and tilting, right? For each of those directions. Do you agree?
No, we could just use what you have to transpose the board.
We'll need to flip the board as well, won't we?
No, we will just rotate the board, perform the rock movement. Rotate the board and do it again.
But transposing isn't the same as rotating. Is it? Or is it? Isn't transposing like flipping in the diagonal?
You are right.
So we will need to...
Yeah, you are right. We need to implement 90 degrees rotation.
Yeah,
either that. There are, I guess, two ways to approach this. We can implement the rotation and then try and memorize it and see if we get lucky. Or we could implement the rock movement in all four directions. And then there is no rotation to implement.
Yeah.
You're driving. I'll let you decide.
That's a good question. My initial thought was to implement all the rotations. It's not difficult, to be honest. But it would be tricky to do. No, this would be annoying to do if it was like from right to left. I think I like the idea of implementing the rotations as well.
Okay.
So what we're going to need to do then is, so right now this just implements, let's make this part 2, yeah? New file. So currently it implements it takes the board and then transposes it, and then I think it should transpose it back. So it basically implements transpose, and then implements tilt, and then it counts in the counts the transpose board, but I think it would make sense to be like transpose back and then count.
The count remains the same, right? It's just we will have to do a billion rotations, or a billion cycles, I should say. A billion cycles, but the counting, this final part that you selected, we don't change.
Yeah, but this is currently done to the transposed board, unfortunately. So we'll have to re-implement this. I think it should really be. This should really be implemented on the standard size board. So we should transpose it back. So this is really, this is, what would you call this? Like north does this. And we can start. How would we implement south then? I think we have to transpose and then flip. On the X. Right?
Wow. I have no idea. I would just take the thing and rotate it 90 degrees instead of trying to transpose it.
Well, it's just that this algorithm only works with the idea that it's heading in a certain direction. So yeah, if we just implement rotate, then we can just rotate it a certain number of times and then it will work. And then we don't have multiple functions to worry about. We don't have transpose and flip.
Yeah.
Does that make sense?
Yeah, I am
Okay.
much more in favor of rotation than transposition and flipping.
Okay, cool. We actually implemented south, didn't we? So we'll need to re-implement this and verify that it works. So for south, well, I guess we have to rotate. Is it left or right? That's the question. So we have a thing that looks like this, and we want this one to be on the top. So we just do one rotation left.
And when you say left, you mean counterclockwise?
Yeah.
Okay.
Or if we just say like 3 times. And north. Is just 90 degrees, right? So 1 time. And then east is well, I guess twice would make sense, wouldn't it? Wait, that doesn't make sense.
And west is gonna be 0 times? But I was thinking that maybe we could do this because we need to do the rotations in order. So wouldn't it make sense to rotate once, perform the rock algorithm, rotate again, perform the rock algorithm, and so on?
Rather than rotating it back here.
Yep.
So instead of undo rotate, we just do. It's going to be a full cycle, isn't it? Yeah. So what is the order that they want us to do it in? Let's just double check. Presumably order is important. North, northwest, southeast.
So it's rotating clockwise.
West, south, east. It would be good if this lined up so that we don't need to. Do you see how we have to go back here?
That's because we are thinking of our rotation as going anti-clockwise, but if we make it clockwise, then it should fall out.
I think I'm thinking of it going clockwise.
So think of the other way. Whatever way you're thinking, think the opposite, and it should fall out naturally.
So if I go the other way, so this is like that. So to get to that, well then this would become
North, I guess, becomes 3 rotations.
Yeah, becomes 3.
West becomes 4 rotations. Or 0, but 4 makes more sense because of my argument of just doing it sequentially. South is either 1 or 5, but let's say 5. And east is either... You see.
Yeah.
And no undos. You don't undo in the end.
No, we don't undo, yeah. Is that right? Let me just work this through. Might be easier to do an Excalibur, but I'm just trying to look at it. So this is, north is definitely 3, because we're going anti-clockwise, and we want that to be on the top, so that it always falls left.
Well, let's go to Excalibur. I like visualizing things. Can you share a link?
Let's visualize it. Cool. Sure. I kind of don't want to throw away the current Excalibur, but I also want a clean sheet.
Yeah, I learned that you can only have one active Excalibur at a time.
Yeah. I think you can manage documents where you have to pay or something. I don't know. Anyway, we'll work that out for next time. So let's do it over here. Let's do this by having the green, the orange, and the blue. If we want to do, we'll say that this is north, and if we want to say that we want to put the north, so this north to south has to be here, right? For our algorithm to work.
Yeah, we are also not completely in love with that part of the algorithm. We could change that.
What do you mean?
Well, we implemented the rock movement going to the left, but we could change that. We could implement it going up or going to the right or going down. It's not terribly difficult to do.
Yeah, as long as we only have one.
Yeah, we could even implement all 4 versions. It's not terribly difficult.
I think it would be annoying.
Okay.
But maybe less annoying than rotating.
Okay.
Now you got me wondering whether we should go for the implementing all 4 versions. Yeah, you just grab it as a string, right? And then... Yeah, it's still annoying though. Because you have to do it from right to left and left to right. You have to flip it and reverse it and work things out. Yeah. Okay. Anyway, let's try with this rotation idea. So to do it to the north, we always need it to be like that. and then we need, so indeed to the left, and then if we want it to be, wait, is it west that they said? Surely they said
Yes.
east. Why did
No,
they?
we go north, west, south, east.
Oh, why can't I rotate this anymore? Oh, I can. Yeah, so north, then west, then south, then east. So that's the weird thing, is that it's going like from here to there to there.
Well, the first movement, you did it with an anti-clockwise movement, but just do it clockwise and rotate 3 times.
Yeah,
There. That's your starting point.
that makes sense. I'm convinced that we can do it like this then.
Okay.
All right. I don't like having to rotate 3 times though. Seems wasteful. Could we somehow simplify that? I don't know. But I guess after we've done
we
one
were
cycle,
going to do 1 billion cycles. Each cycle has 4 rotations. So we are doing 4 billion rotations, and you're complaining about the 3 rotations we do to start? That's wasteful.
Yeah. Okay. Let's implement rotate then. And I'm gonna just delete all the rest of the code because it's in another file anyway, so if we need it we can get it.
Okay.
I'll get rid of this width height, that was very useless. Okay, so rotate board. Let's see what Copilot has for us.
Now, given that the rotation is going to be called 4 billion times, can we try and optimize it and do it in place without creating a new board? Because line 259 is going to stress the garbage collector.
259. Yeah, but aren't we going to need to not do this in place so that we can memorize things?
Ah, right. Yeah. You are right.
Although we can always concatenate it into a string.
No, because then we would need to be fishing strings out of the... No. Yeah, go ahead. What we have is nice. If it is correct,
Well,
I don't know.
Well, we're still going to need to get a cache key.
Right, the
to
cache
see
key
it.
is just JSON stringify board.
Yeah. Okay. So,
And if you have a way to install Lodash real quick, we can use Lodash to memorize instead of having to roll out the memorization multiple times.
I could install Lodash, but memorization, we'll see.
Okay.
So, I'm not sure this is correct because shouldn't this be the rows should be now the length? Yeah. Oh no, that is correct.
Can we test it? Can we see a board before and after?
Oh yeah. Sure.
Cool. And I will ask you the favor of pasting the results back into the file so we can see it.
Yeah, let me just... because it's pretty useless. Oh wait, hold on. Oh, I'm printing the wrong thing. That's why. That should print it how we want, I think.
No, you're throwing away the board. And why does even join passive function? I'm not sure.
Sorry.
Yeah, that.
Okay, it's a bit unnecessary, but anyway, would have been much simpler if it just wasn't in the same console log. But this is kind of a difficult one to look at. Maybe we should put a simpler one in. But this is the board.
Yeah, let's do that. What you just said, I will take care of it.
A simpler one?
Yes, I'm creating a simpler input that will make the rotation obvious.
Okay, cool. And I'll change this so that it's a little bit easier to read.
Two, 4, 6, 8, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There, I have a board.
Lovely. And let me just... Looks pretty good.
No, it does not look good at all.
No?
This is transposing,
me-
this is not rotating.
Oh dear. Alright, let's read it. Let's read the code then. So, yeah, that's annoying.
For it to rotate, we will need to see in line 277 something that amounts to something.length, maybe board.length or row.length, minus j or minus I. But there will be a subtraction in the code. Trust me.
So we're going to need to create the number of rows, and then we're going to need to populate I'm just trying to think about how to do this.
Okay. While you're thinking, I'm going to satisfy my curiosity and see if Lodash has any features for matrices. Ah, that's too bad. It would be cool. I wonder if there are libraries for manipulating matrices in JavaScript. Of course, it would be something that we could do in a couple minutes, but it would be nice if there was some library for this. Transformation matrix, 2D array rotation, transformation matrix JS, rematrix. And it's fairly popular too. And it can flip, it can rotate. Cool. And this can rotate as well. This one is not super popular, but all right. Yeah, that's a different story. Anyway, I'm back.
Yeah, it's annoying that the transposition for the first one is the same as the second. is the same as rotating left.
Well, for this example it is, because in my example I only have one line of rocks, but if you had another rock here,
Yeah.
or sorry,
Would that show the issue?
yeah, it will show the issue. Because the zeros are supposed to go up. Or actually, the way that we want to do it, the O's are going to go to the right and the zeros are going to go to the bottom.
I think we want to do anti-clockwise though, for it to be 3x like we thought. I guess it won't really matter. We can always just do 4 or 3 and then 4 and 5 or whatever instead.
No, we have to do this
Like,
in the right direction, because then the initial setup it doesn't matter, but for later we want to do north, then west, then south, then east. So we want to rotate this thing clockwise. The O's need to go to the right, the zeros need to go to the bottom.
Okay, yeah, you're right. So the I's need to go up top, and the zeros need to go. Actually, no, zeros need to go to the right.
And the I's to the bottom.
Yeah.
Yeah.
I agree with this initial construction that it's going to have the number of rows is equal to the number of columns. And then, does it make sense to build each new row?
Yeah, sure, why not? You can do it row by row or column by column. The tricky part is just this last line here. And besides, this last line is... okay, it's doing the right thing. I thought I saw a mistake, but there isn't a mistake.
So here we're iterating through each row of the board?
Yeah, of the inputs. So think of, again, of line like 235. That line of O's, we want it to go to the right. So, for instance, this coordinate needs to end up here. And that coordinate needs to end up there. So all the setup that is doing row J, for instance.
This makes sense.
This makes or doesn't make sense?
It does. This, I think this, it feels right. I guess I'm not quite seeing it.
Well, think about, for instance, this one. It's coordinate 0, 0, right? We want it to end up here, right? And what is this coordinate? It's 9, 0.
Yeah.
Or actually, because we are indexing by
0, 9.
0, 9. Yes, because we're indexing by line first. So we want it to be 0, 9. 9 being the length of the board. And the rotated thing is not using 0, 9. It's using 0, 0. So that's not right. We wanted it to be 0, 9.
Yeah.
So that's why I say that there is a board length minus I situation happening. In line 272, there must be...
Right. Yeah, so this is the... initial... Let me get rid of this. So for this row column, this J is correct, but this I Maybe. Is that correct? That looks more correct. Yeah.
It's still transposing though, because here it's using JX and here it's using IJ. Or maybe not. It seems like it's doing the right thing, so forget what I said and carry on. The zeros or the O's are going to the right, the I's are going to the bottom, and so on.
Yeah. Okay.
You did it.
Yeah. Just about. Okay, so now we are rotating it. We need to implement tilt.
Yeah. Can we implement tilt with my silly algorithm? Okay.
Yeah, let's do it. Let's do it. Does that look right? I don't even know. I'll try and use your algorithm. So with something like replace all of the .O's with O dots in each line.
Yeah, and you have to keep doing that until it doesn't change the string anymore.
One question is, do we want an array of strings or an array of strings? Because having an array of strings would make it easier for this manipulation.
Oh, right. Rotation wants to see an array of arrays, and tilt with my silly algorithm wants to see a string.
Yeah, but I think, we can always concatenate these and then, add a string, right? You see what I mean? Although, are we... Yeah, because we're still always adding these in row order, so it should be fine to do this. We'll stick with an array of strings.
I see what you're doing. You are doing what in Java we call a string buffer, I think, where you are going to be appending to the buffer, and then in the end you're going to join.
Yeah.
I measured once, and it is faster to do plus equals on strings than it is to push and then join.
Oh, really?
Yeah, but you have to turn this into a let, which I will do for you real quick.
This is not going to work, though, because this is not going to be, like, moving one at a time.
So forget about it. Let's just either do the algorithm in your way, or convert into a string and then do the silly algorithm and then convert back. Because hopefully this will not matter because it will be memoized.
Yeah, it's not going to be our thing, is it? Okay. A board. As list of strings. That makes sense. Now we'll need to. We need to go by row, don't we? And then for each row, we want to do rows. Is it .o? Yeah.
Correct. It doesn't even need to be a regular expression. It can be a string. It's faster if it's a string.
Oh, yeah?
Mm-hmm.
And it needs to be replace all.
It can be replace or it can not be. It doesn't really matter all that much because we are doing this until the role doesn't change anymore, right?
But if we do replace all, doesn't it? Maybe it doesn't actually. Do that and that while there are none of those. Oh, it's pretty nice.
Oh, this is even worse. It's gonna go over the string yet again to check. I love it.
But it's pretty good. pretty concise.
Yeah.
And then
I'm having the time of my life here with this algorithm.
and then we convert it back at the end.
Yep.
And then finally we need to implement count, which let's just assume this is implemented for it's from north to south. It's like in the same orientation that it came. So we just go through each row and then we count the number of O's, and
I'm on board with that, yes. So to begin in the main algorithm, we are going to rotate 3 times and then starting doing rotation and tilt 4 billion times. Then we are going to rotate once. After we are done, we are going to rotate one last time so that the north is at the north again, and then we are going to count.
Yeah.
What do you think are the chances that this is going to run in reasonable time for 1 billion rotations? Or 1 billion cycles, which is 4 billion rotations?
0. I think it's board dot length minus I. Is that right?
Mm-hmm. Looks right to me.
And then return sum. So we just need to validate that we got this right for the example.
Yeah. Let's validate that tilt works by itself. Let's validate that count works by itself, and then we do the main algorithm.
Yes. So, let me just bring this up here and have a look. So the first thing we need is this input, not this one. Is this the source input or is this the rotated? Yeah, so we don't want this one. Fine. So we want to first rotate it so that it's north, right? So that we can do the north rotation.
Oh, you're writing the main algorithm now.
Oh no, I'm just rotating it so that we can do the example one. I'm not writing the main algorithm. I'm just rotating it. It's just that we have to rotate it 3 times, right? So that we can even do the like that, and then finally we have to rotate it once again.
Yeah.
This is fun. And then count that. I'm a functional programmer.
No, wait a second. Don't put the count there. Let's just see if tilt is doing the right thing before we count. Because for counting, we actually need to do a full cycle. We don't want to just rotate and tilt once. You want to rotate and tilt 4 times, then one last time to get the north back on north.
Yeah. So this will be the last time. So
No.
we'll output
No, it
the
isn't.
rotation.
No, it isn't. In the example, they do a full cycle. A cycle is 4 rotation and tilts.
Oh no, I was just thinking to validate the part 1.
Okay.
Because that's just simpler. But I will definitely do part 2 in a sec. So rotate. Anyway, it seems to be breaking. Board.map is not a function. On line 266. Do you want to check if you can see the terminal?
Well, I will be able to see it for a little. It's just, it breaks, but I requested.
Okay, I will kill this terminal, and then I will create a new terminal.
I see that, yeah.
And then I will go into 14. Okay, now you can see the errors. Errors. Okay, 266. Is it because I'm overwriting board every time? I'm just going to call this board 1, so that I don't run into this issue at all.
Same problem?
Yeah. I also don't see why. Line 266. So
What is... We are calling tilt with the result of rotate. So let's print the board before we do 266 and see what comes out of it. JSON stringify or something? Or maybe we have the dot join in the wrong place here? Yeah, these dot joins are definitely in the wrong place. At least one of them, at least this one. Because it's not in the same place as the other ones. So one of these is wrong.
Well, that could be true.
Yeah, right. That's exactly it. Line 292. We are doing the dot join and then passing the result to other stuff.
Okay, that'll be it. Thanks. So it should be there.
Nope. Don't dot join the count.
Okay, so now it's kind of working. And now we're getting an error in this replace all.
That's simply a matter of let.
Okay, thank you. And that's probably a similar one, yeah. Okay, 136, that's our answer. That's actually what we wanted as well. If I remember correctly, that number does ring a bell.
Yes, you are right. Good job, hey. Good job.
Okay, now we just need to do this 4 billion times.
Oh yeah, sure.
Okay, let's do the... Should we do the example then after one cycle and see if it looks like this?
Yeah.
So what this is going to look like is rotate. We have to rotate. Is rotate the board 3 times?
No. You have to rotate and tilt. Rotate and tilt. You don't rotate, 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 tilt, tilt, tilt.
No, but I need to get it north, right?
Ah, so you're doing the main program now from the top. I thought that cycle was just gonna be one cycle, but it's doing the full algorithm now.
Yeah, it's gonna do one cycle of rotation and tilts.
Okay, so if it's doing one cycle of rotation and tilts, assume that it's receiving the right board in the right orientation for the cycle to start.
Oh yeah, that makes sense. So start with it like this.
Yeah. So rotate, tilt, rotate, tilt, rotate, tilt, rotate, tilt. And I think it's very cute that you are giving variable names to these intermediate things. Why are you doing 2 rotations? Don't do 2 rotations.
Oh yeah. Because I'm already, yeah. So we want to do northwest, south, Yeah, it would make sense to not do this. Yeah.
That's that. Return east.
Yeah. Okay. And what I'm going to do is then I'm going to ask never mind. Okay, cool. So that's
and I
fine.
would argue that it makes more sense to tilt and rotate and not to rotate and tilt, because then we can provide the board in the right orientation to begin with.
Yeah. The issue is that we need it to know which orientation it is when we count it.
No, let's suppose that cycle does one cycle. So it will receive the board already in the right orientation, and it's going to deliver the board in the right orientation, which in our case is the north to the left. But I propose that cycle is tilt and rotate 4 times in a row. Then in the main body of the program, we have 3 rotates, 1 billion calls to cycle, 1 rotate, and then count.
Okay. So it shouldn't, is what you're saying, it shouldn't rotate it initially?
No, what I'm saying is that we should swap tilt and rotate in these lines.
Okay. All right. Yeah, that makes sense. So here tilt, then rotate. Then tilt. Struggling to type there. Yeah, this isn't going as well as I wanted, this typing method. So how many have I got here? That's tilt, that's north, west, south. Then I need to rotate once more, and tilt once more. Does that make sense?
I want one more rotation in the end, and that makes sense.
So this will be east. Yeah. Does that make sense?
Yeah.
Okay.
Yeah.
Cool. Well, let's print cycle of board 1 dot join. So I don't know if you can see the output.
Well, I see the output, but I have a hard time making sense of it because it will not match, and we know for a fact it will not match the example in the page. So I would like to see the example in the page.
Yeah.
And for that, I guess we need to flesh out main.
Yeah.
To do the
Sorry,
setup of 3 rotations and then the tear down of 1 rotation.
Yeah. let me. Yeah. Okay. So. Okay. Let's just do it in here then. Okay. I don't know why it's adding all these commas.
Because the join in the array of arrays is going to do
Yeah.
one array deep, and the inner arrays are going to be stringified, and that separates things with commas. But never mind the commas, David, because it's doing the right thing. Hooray!
That's what I want. Does that look right?
It does. It does look right. It is right. Good job. So now do it a billion times.
Brilliant. Okay. And then for
That's just 100 million.
Is that done? Have you done that correctly now?
No, can I type?
I just wanted to check that, and then I just also want to. Yeah. Let's do that. Oh, we better count at the end. Oh, that's a lot. That's too much printing. Oh.
Yeah, and now the terminal is broken on my side.
Is it? There's too much output.
Yeah, when it outputs too fast, it barks the terminal for me.
Okay, I will kill the terminal and then make a new terminal, and then you should see the output.
Step by step, everyone. Are you in a hurry? I'm not.
So this is 100,000. Let's say it's taking, I don't know, 3 seconds.
Something like that. And just look at that 1 million. Woohoo! We just have to do 1,000 of those.
Okay. Yeah.
If it is taking like 1, 2, 3, 4, like let's say 4 seconds, and we need to do 1,000 of those, that's 4,000 seconds, which is
It's gonna take like a year.
66 minutes or 1 hour. It's not so bad.
Oh yeah?
Yeah. Of course, we're talking about the small input example, right? If we do this in the bigger board, it will take a lot longer.
Oh yeah.
But I guess in 1 hour, we would be able to do the example.
Yeah, that's true.
Now,
Okay,
throw
should we-
in some
should we-
spices and some curry and...
Let's so should we go for detecting cycles first, or should we look at memoizing rotations?
I propose that first of all, we memorize tilts.
Okay.
Because the tilt works at the line level, and that's where we will see most structure, I think. So memorize tilt and run it again. You will see.
Do you want to memorize at a line level or at a board level?
No, at the line level. I think that we want to memorize the work that we are doing with the replace alls.
Yeah. Yeah. Okay. I'm going to call this tilt row. Otherwise, yeah, that. Should we time how long it takes to
Line 273 doesn't look right.
Oh, really?
We are mutating the
Oh,
parameter. We should keep it around. Yeah.
Key and key.
Okay.
And I think I just want to. I just want to get a sense of how long this is taking, doing some timings,
Okay.
and how much we're speeding things up.
Okay.
I'm just wondering what the best way to do that is. We could time every single cycle, but that's going to just be too much, I think. So
We could
We'll
do
want to
it.
do it.
We can do it ad hoc just by looking at how often we see the console logs. Like I counted 4 seconds, and if we want to make this feasible for the
Yeah.
bigger board, we need to see the difference on the console. It needs to feel really fast.
Yeah. Okay. I think that's faster.
I'm underwhelmed.
I'm underwhelmed too, but it feels faster.
I suppose next we try and cache the tilt, the rotation. We try and cache the rotation.
Yep. Yeah. I still think it's going to be. That feels slower.
Geez, Jason Streakify is slow.
I guess so. I mean, we are stringifying and quite a big. That's going to be a lot of work on its own, isn't it?
Yeah.
Aww. Should we look at cycles?
Well, I think we already proved that there are no cycles, right? Because otherwise the memoization would help.
I'm not sure how much stringification versus doing this is actually that much faster.
Well,
Like,
can you show how many cache hits we are getting?
absolutely.
Yeah. We are hitting the
A lot
cache.
for a lot for 2. I guess this is going to break the terminal, isn't it?
It did, but it seems to be hitting both caches.
Yeah, a lot.
So, good news, the problem is memorizable. Bad news, our memorization keys are slow to compute.
Yeah. If we had a different language, this might be better. But I think it's more that, like, if there's cycles, we can just work out where the cycle is and then compute out the index.
Yeah, so I guess the next job is to, every time that we are doing a cycle, we store the board and compare it to previously stored boards and see if we find one that is exactly the same. And then at that point, we can stop the rotations and work with numbers only.
Yeah, exactly. Although, no, I think what we need to do is not just like stop when we see that board again. Stop when we see that board again and we're on the same part of the cycle? Or is it just we keep cycling? Yeah, I think if we just do like previous boards.
No, I want the sense of ordering, not just a set. Because I will want to look at, let's say, I am in rotation 700, and I happen to see, or I'm in cycle 700, and I happen to see a board that I have seen in cycle 600. Now I know that there is, let's say, a cycle,
need to know that.
a cycle of cycles.
Yeah. So let's do it like that. And then if then we console.log and break. Otherwise we append the board. Are you seeing my new terminal? Okay. Do I have? Yeah, I do. Out is not defined. Out is not defined. How did this even work? I guess we never got there. Okay. Right. That makes sense. Should we verify that this happens at 69?
No, not at 69. 69 is the count. That's line 323. The cyclone was found at 9.
Oh, yeah. Should we verify that it happens at 9 by not breaking?
No, I believe your code. Previous boards includes JSON stringify.
Oh, I've broken the terminal for you again. I just want to check that these happen every...
Yeah. We are in a cycle. You're good. You found the cycle, David. Now work with the cycle to avoid doing a billion rotations. Because now we know that cycle number 9 is equal to cycle number 0. So we can fast forward to near a billion.
Oh, sorry, no. This is saying that it's just that this... Yeah. No, this is just saying that what I really want is the index, right? But that's okay. We're in a cycle. They're all in a cycle. That's fine. Okay, then now that we know that, this is going to tell us the index of the. I guess this is the cycle length.
Yeah, the cycle of cycles. It's I have to keep track of it in my head.
Mm.
And besides, I is not defined in line 321. It's scope finished on the line above.
Yes. Well, that's fine. We can just.
Cycle of cycles. Gotta love these things.
Okay, that's fine. Then when we have that, we need to compute the. What is it that we're trying to compute again? The let me look at the problem description. We just need to say where it will be or count it after 1 billion cycles.
Yeah. So you can skip forward.
Okay, so we need to. So we need to index this. So is it just like is one whatever this number? Not. Actually, I don't think we even need that.
You know what I would do? What you're doing is smart.
Get that board out, and then.
Yeah, what you're doing is smart. You know what I would do? I want to share this because I think it's fun. When you detect the cycle in line 316, instead of breaking, what I would do is I would modify I to skip ahead. Carry on.
So you would just do it so it's like multiplied by the length.
Yep.
But less than.
But that's less than a million, yeah. A billion.
Yeah. That's very cool. I like that. Let's do that.
Oh, you want to do that?
Yeah, that's cool. So I should now equal math.floor is that right? I don't know why this is here. Oh, sorry. How does that look?
I think
It's like
it's not quite there. There are two things that I think are not quite there. The first is that once you do the jump ahead once, you need to stop trying to do it again.
what's that? Once you do the what?
Once you do line 318, you don't want to do it again. We are going to skip ahead as much as we can, but we don't want to keep trying to skip ahead.
Oh, I see. Because this is complicated to think about.
So go with your approach. That approach was also nice.
Yeah. I have to think about this deeper. Mine was going to work though.
Yes. That.
So we get that out. Don't quite want a JSON parse. We just want to. Oh, JSON.stringify is terrible. I don't want to stringify. Or do I? No. Do I? Could I just paste JSON past that? Will it just work? I think it will, you know.
Yeah.
And then rotate it, and then does that work? 104. Is that the answer they want?
I think it's
No.
64. Yeah, I think it is
Yeah.
64.
I mean, I found
Well, I would say that you don't want the previous boards at this index. Or maybe you do. Let me think. Oh yeah, I guess you are right. I think that's what you want. Maybe there is an off by one mistake. Can instead of 1 billion, can we do like... no, because then we will not find a cycle of cycles. Yeah, I was going to ask to just do after 3 cycles, for instance, but then we don't find a cycle of cycles in 3 cycles.
I guess we should just debug it for smaller inputs, and then we'll find the off by one error. If there is one. I mean, I could try this. No.
And they did not do the favor of giving us the board after 1 billion cycles.
Was it 68? No, it was 64. Okay, so... yeah, maybe not off by one. And I don't need to append one more board either, because this one is already in the cycle. Is it possible?
Well, but you broke
that
a both, so that's alright.
I do wonder though if the cycle happens like at an offset. Like, do you know what I mean? Like, again, it doesn't happen right at the start. It doesn't go back to the beginning.
That's then, yeah, that makes sense. It's the same problem we had with the graph traversal in day 8.
Yeah. And then this wouldn't work.
Correct.
So should we verify that?
Well, we can by checking not that the previous boards includes the board as in line 315, but we can detect in which index it includes the boards. Don't call it I. I is already the variable that you look over.
And I'm just gonna do like... I'm just gonna do this for like 100
No,
so that...
don't do that. Backtrack. Keep the break. Don't use the else. You don't want the search to continue.
But I just don't... I want to see how it's creating these indexes. Like how it's... where it's finding the index.
Okay.
You see what I mean?
Mm-hmm.
So it goes 3, 4, 5, 6, 7, 8, 9, 3, 4, 5, 6, 7, 8, 9, yeah. So yeah, the offset is somewhere not at the start.
Okay, well, that's easy enough. Just remember the prev index, subtract it when you're doing modulo, and add it back when you're indexing.
Yeah. Okay. That's not what I want. What I want is the cycle offset.
You also want the cycle
then-
length. But that's
I
just
have
the
that from
length
the
of the previous
previous-
boards. Yes, right.
So the previous index.
Just remember prev index. That's all.
Is that all I need?
Yeah, cycle offset is equal to prev index.
Mm-hmm. Okay. And then the index, you said take it away and then add it back.
Yeah, I mean, take it away from here.
Hmm.
And add it back there. Or similarly, add it back after the modulo, assuming that modulo happens first. So I'll put some parentheses there.
68. Not 64.
We have seen that before.
We have seen 68 before, yeah. But now I suppose there could be some off by ones. No, 63. Let me think this through. So
Can we try an off by one here?
'68.
Huh. Isn't that something?
Yeah. Oh, I didn't save. 65.
It's in the neighborhood.
They're all so close. Yeah, I'm not sure. So we have this build up, then we have the cycle, then we have these cycles here, so this offset, and we want to like index somewhere in the future. So I want to find out where it will be at this position. Yeah. Yeah, so that's why we need the cycle length. Where will that be? In a million positions. Let's just, if we can just extract const cycle length. I also have a kind of crazy idea, which is we just go through each of the boards and work out which board is the correct board from our existing boards to make sure we have the answer, and then we work out backwards how many, you know, how to do it, how to do the formula. But
And you probably want to remove
So
this
the
plus
cycle-
one, which was just me guessing, and
yeah,
it didn't work out.
let's just paste it. So we don't quite want to. It's weird because we want to work out where this will be in a billion, right? And then we need to take away this portion
Ah, here is something.
or add.
What if, I'm taking out the +1 from there. What if we also want to remove the cycle offset from here before we do the modulo? Does that make any sense?
Oh, that does make sense. Yeah. And then we don't need this here.
We do.
We do. Because we need to, because these boards still have
Yeah.
them. Okay. Okay. Let's try that. 64! Hey! Very nice, very nice. That makes a lot of sense. Alright, should we do it for the real deal?
We should. Can we do it for my inputs?
Yes. let's do it for
Selfishly, I
yours.
ask.
Oh, that was quick.
That was quick.
It's all that memorization.
And what is my answer?
Please. Oh, sorry. Oh, I thought you pasted it already. Can you not see the output?
I see the output, but I don't know which one is mine.
Okay, I'll kill the terminal. I'll run it for yours again.
Thank you.
This is yours.
So the answer is 86,000 something something.
Mm-hmm.
That's the right answer. Good job.
Hey! That is brilliant news.
Good job,
Glad I could
David.
have helped.
Well done.
Eesh! All that rotation.
Rotation,
We still-
memorization, and some cycle of cycles stuff. Wow, not bad, not bad.
Not bad. I mean, I don't think it was the hardest, but it wasn't the easiest either.
It was not easy. Let's see what people had to say here. Not was one says hi. Hello, not was one. So, do you want to do day 15?
I do.
All right.
Can you hold on 1 second? Have a quick 1 second break. I just need to chat with somebody.
Okay.
Thanks.
While you are doing that, I will be quickly going over the Reddit for day 14. And get a hold of those Vim solutions and stuff like that. Python. Part 1 only. Somehow I lost the cycle detection part. We'll rewrite later today. Today's trick. Instead of separately checking whether a rock moved and then moving it, just do string replacement. Haha! I got that trick! It's horribly inefficient, but fast enough for today. Who's counting, right? Okay, Vim keystrokes. That's the one that I want to see. Another nice visual one. So I put the redraw and sleep step in to see the rounded rock sliding north. The lesser spotted blah does most of the work today. The first line is exactly the same as the star, blah, blah, blah. So I think it's just padding the board. And then do the dot and O swap. Pretty much in the same way that we did with string replace. And
Hello.
hello.
Sorry about that.
Yeah, what I was seeing is that the top answer here on the Advent of Code subreddit includes the trick of doing the string replacement just like we did.
Well, there you go.
And I don't think I get it. Oh, but they're doing collapsing cycles, so they're detecting cycles of cycles.
Yeah.
And I see
that?
that.
What's the decorator? What's the decorator there with the KS
It's
funk?
something that they did. It's this person.
It must be for memorization.
I wouldn't be surprised. I guess in this case it's for summing. But anyway. Rolling, but always rolling north, but rotating the grid 4 times. Okay, people are doing their rotations. And then there is, of course, this makes a lot of sense. I love this. Google Sheets, nice. One expression, regular expressions. All right, someone figured out how to do the regular expression that I was thinking about. And this is painful. All right, enough of this. Let's get to day 15, everyone. Day 15, lens library. The newly focused parabolic reflector dish is sending all the collected light to a point on the side of yet another mountain, the largest mountain on Lava Island. As you approach the mountain, you find that the light is being collected by a wall of a large facility embedded in the mountainside. You find a door under a large sign that says Lava Production Facility, and next to a smaller sign that says Danger, personal protective equipment required beyond this point. As you step inside, you are immediately greeted by a somewhat panicked reindeer wearing goggles and a loose-fitting hard hat. I guess a yellow hard hat, right?
Would you mind resharing your screen? It's frozen.
How's that?
That is good. Okay. Thanks.
The reindeer leads you to a shelf of goggles and hard hats. You quickly find some that fit, and then further into the facility. At one point, you pass a button with a faint snot mark and the label Push for Help. No wonder you were loaded into that trebuchet so quickly. That was day 1. Yeah, I remember the trebuchet thing. You pass through a final set of doors surrounded with even more warning signs and into what must be the room that collects all the light from outside. As you admire the large assortment of lenses available to further focus the light, the reindeer brings you a book titled Initialization Manual. Hello, the book cheerfully begins, apparently unaware of the concerned reindeer reading over your shoulder. This procedure will let you bring the lava production facility online, all without burning or melting anything unintended. Before you begin, please be prepared to use the Holiday ASCII string helper algorithm, Appendix 1A. You turn to Appendix 1A. The reindeer leans closer with interest. The hash algorithm is a way, hash is this, Holiday ASCII string helper, hash, okay, is a way to turn any string of characters into a single number on the range of 0 to 255. To run the hash algorithm of a string, start with a current value of 0. Then for each character in the string starting from the beginning, determine the ASCII code for the current character of the string. Increase the current value by the ASCII code you just determined. Set the current value to itself multiplied by 17. Set the current value to the remainder of dividing the value by 256. After following these steps, for each character in the string in order, the current value is the output of the hash algorithm. So, to find the result of running the hash algorithm on the string hash, blah, blah, blah. We will use this when we start implementing it. So the result of the blah, blah, blah is 52. The initialization sequence, your puzzle input, is a comma-separated list of steps to start the lava production facility. Ignore neoline characters when parsing the initialization sequence. To verify that your hash algorithm is working, the book offers the sum of the result of running the hash algorithm on each step in the initialization sequence. For example, blah. So this initialization sequence specifies 11 individual steps. The result of running the hash algorithm of each of these steps is as follows. So r and n equals 1 becomes 30. I'm not sure I understand. What is up with this? Let's try and read this again. It specifies 11 individual steps. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The result of running the hash algorithm on each of the steps, so the hash of this is 30, the hash of that is 253, and so on. Okay. In this example, the sum of these results is that. Well, luckily the sum of the results and calculating the hash is a sum, so we just need to remove the commas and compute the hash of the whole thing. Unfortunately, the reindeer has stolen the page containing the expected verification number and is currently running around the facility with it excitedly. Run the hash algorithm on each step in the initialization sequence. What is the sum of the results? The initialization sequence is one long line. Be careful in copy and pasting it. Here is our puzzle.
For once, I think we have a strong indication that what's going to come in part 2 is something to do with the numbers on the right-hand side of each of those.
Numbers on the right-hand side of each of those? I have no idea what you're talking about. All right, so let's do some busy work here. I will open a Visual Studio Code with Advent of Code, day 15. Oh, not really. It's day 14.1. And they...
Do you really have no idea what I meant, or you were just joking?
Close the session. I was copying the code.
Oh, sorry. My bad.
Send it to me later. That's all right.
Do you want me to share it again?
No, just send it to me later.
Push it up? Okay. Sure. Sorry, I think there's a bit of lag at the moment.
Yeah, there may be. Even starting the collaboration session is lagging. It must be my internet connection. Even the stream is like struggling right now. Oh, shucks. But while we wait. All right. I have the link to send you. I guess I will be keeping things simple here and just do one long line like that. And the example input is this. And if I understand things...
Did you share your VS Code with me?
I did.
If you could send me the live... If you could send it again, I got it now. I've got it.
You got it? Okay.
Thank you.
So, I am going to console log input dot replace all commas with nothings. I am going to reduce starting with a 0, and I will get my hash and my character, and I will add to the hash the... Oh, it's not that simple. Or maybe it is. Let's keep the code here and the inputs there. So, determine the ASCII code. That is my character. Char add code point add. It's something off, right? Index off, add No, code point at, that's going to be Unicode stuff. Charcode at, I think that's what it is. So if I get the underscore a, the lowercase a, for instance, should be 60. Or maybe it's uppercase a, 65. Yeah, I think we got it. So we are going to use charcode at. So first, determine the ASCII code. Done. Increase the current value that you just determined. Done. Set the current value to itself multiplied by 17. Done. Set the current value to the remainder of itself divided by 256.
This would this function for a very good hash? I suppose it wouldn't.
Reduce is not a function because I am using it on a string. (168) and the result of the running hash is 52. Oh, but that's on the string hash. So input hash 52. So then,
Nice.
oh, but I shouldn't just do this because I will want to add them without the modulo. Okay, so let's backtrack a bit. Let's split on the comma and then reduce starting at 0. And this is going to be my sum. And this is going to be, what do I call this? Steps, right? 11 individual steps. So this is my step. And what I want to do to my step is this. All right.
Nice. Nice. Record time.
Oh no! Yay, that's the right answer. 1 gold star. Woohoo! Woohoo! Continue to part 2, everyone.
Woo! That was.
You convinced the reindeer to bring you the pay. Oh, sorry, you were celebrating. Woohoo! High five!
There's a bit of a delay, sorry.
Part 2. You convince the reindeer to bring you the page. The page confirms that your hash algorithm is working. The book goes on to describe a series of 256 boxes numbered 0 to 255. The boxes are arranged in a line starting from the point where the light enters the facility. The boxes have holes that allow light to pass from one box to the line. Inside each box, there are several lens slots that will keep a lens. Inside each box, there are several slots. Okay, that will keep a lens correctly positioned to focus light passing through the box. The side of each box has a panel that opens to allow you to insert or remove lenses as necessary. Along the wall, running parallel to the boxes, is a large library containing lenses organized by focal length, ranging from 0 to 9. The reindeer also brings you a small handheld label printer.
1 through 9.
1 through 9. I misspoke?
Yeah.
Okay. But yeah, the focal length ranges from 1 through 9. I suppose inclusive. The book goes on to explain how to perform each step in the initialization sequence, a process it calls the Holiday ASCII String Helper Manual Arrangement Procedure, or HashMap for short. The book goes on to explain how to perform each step in the initialization sequence. Okay, each step begins with a sequence of letters that includes the label of the lens on which the step operates. So lenses are labeled, and lenses have focal lengths. The result of running the hash algorithm on the label indicates the correct box for that step. Okay, so for instance, if we have this instruction, rn equals 1, rn is the label of the box, so I'll hash rn to indicate in each box I need to be. Good. The label will be immediately followed by a character that indicates the operation to perform, either an equals sign or a dash. So in that case, it was equals 1. If the operation character is a dash, go to the relevant box and remove the lens with the given label. What is the lens that I need to remove? I have been given the lens, I have been given the label of the box, not the label of the lens. That is confusing. I want to take it from the top. Inside each box, there are several lens slots that will keep a lens correctly positioned to focus the light, the side of the box, blah, blah, blah. The reindeer also brings you a small label printer. Okay, the book goes on to explain how to perform each step in the initialization sequence, a process it calls the hash map. Each step begins with a sequence of letters that indicate the label of the lens on which the step operates. So it's not the label of the box, it's the label of the lens. The result of running the hash algorithm indicates the correct box for each step. So there is like a huge assortment of lenses. They each have an individual label, and the hashes of the labels will determine the box. So because there would be multiple labels that correspond to the same hash, there will be multiple lenses in the same box, but each label corresponds to a lens, and each hash of a label corresponds to a box. Now I'm following. If the operation begins with a dash, go to the relevant box and remove the lens with the given label if it is present in the box. It may not be. Then move any remaining lenses as far forward in the box as they can go without changing their order, filling any space made by removing the indicated lens. If no lens in that box has the given label, nothing happens. If the operation character is the equal sign, then it will be followed by a number indicating the focal length of the lens that needs to go into the relevant box. But the equal sign is coming after a label. A label is already assigned to a lens, and a lens will have its focal length already. So this does not make sense to me.
No, it doesn't really make sense to me. Let's have a look at the example. It always makes sense to me after the example, so maybe.
This is thoroughly confusing. Let's see if I have another false assumption. Each step begins with a sequence of letters that indicate the label of the lens on which the step operates. Okay, so we'll have a label for the lens, but we will not necessarily know the focal length of that lens. That's what's after the equal sign. So by using the equal sign, we can assign lenses to their focal lengths. I think that's the point. Indicating the focal length of the lens that needs to go into the relevant box. Be sure to use the label marker to mark the lens with the label given in the beginning of the step so you can find it later. So even if there are multiple lenses with the same focal length in the same box, I still need to be able to differentiate them. That's what the lens label is for. There are two possible situations. If there is already a lens in the box with the same label, replace the old lens with the new lens. Oh, so there are lenses with the same label. If there is already a lens in the box with the same label, not the same focal length, the same label. So there will be multiple lenses with the same label now. Replace the old lens with the new lens. Remove the old lens and put in the new lens in its place, not removing any other lenses in the box. But if the lenses have the same label, they may not have the same focal length. So there could be like Rn equals 1 and then Rn equals 7. because there are multiple lenses with the same label, but not all of them will have the same focal length. That's why you're doing the swap. Otherwise, you would be swapping two things that are equal. Okay, if there is not already a lens in the box with the same label, add the lens to the box immediately behind any lenses already in the box. Don't move any of the other lenses when you do this. So it's like a stack. If there aren't any lenses in the box, the new lens goes all the way to the front of the box. Here is the contents of every box after each step in the example initialization sequence above. So, after Rn equals 1, the box 0 will have Rn 1. Well, that is only the case if Rn hashes to 0. Let's see if that's the case. Yes. And then we put it on the stack. Then, after CM minus, we try and go to box 0 and remove CM. But it's not there, so nothing changes. After QP3, we go to box 1 and add QP3 there. After CM2, we go to box... Oh, we have done this already. We know it's box 0. So we go to box 0 and add CM2 there. After QP minus, we go to box 1 and remove QP from there. So there will never be in the same box two lenses with the same label. Well, there may be, because they may have different focal lengths. So let's continue. After PC,
is that true?
I suppose that's why they're adding the focal length to the label here. So I suppose the QP is going to be a QP minus, for instance. If there are two QPs in the box, we want to remove the first from the top of the stack. It's going to be wildly convenient that the array data structure in JavaScript can be both an array, so we can remove stuff from the middle, as well as a stack, because we can do pushes and pops.
But what couldn't... is it possible that you saw QP3 and QP2? If you get a QP minus, will it remove both of them?
Ah, that's a good question. I think it removes only one, but let's see. Go to the relevant box and remove the lens with the given label if it's present in the box. Then move any remaining lenses as far... Okay, so it's not saying anything about two lenses with the same label in the same box, so I suppose that just doesn't happen.
Okay.
After PC equals 4, PC hashes to 3. So we go to box 3 and put it there. OT 9, OT, I'm gonna bet it hashes to 9, so it goes there. And I bet that this hashes to 3, and I said the wrong thing before, but it goes there. After PC minus, then we remove PC minus from box 3. After PC, PC6. So see, it removed PC before adding another PC.
Okay, I had no idea what the hell this was about until we went through the description, and now I fully understand it.
All 256 boxes are always present. Only the boxes that contain any lenses are shown here. Within each box, lenses are listed from front to back. Each lens is shown as its label and focal length in square brackets. To confirm that all of the lenses are installed correctly, add up the focusing power of all of the lenses. The focusing power of a single lens is the result of multiplying together 1 plus the box number of the lens in question. The slot number and boxes start numbered by 0. The slot number of the lens within the box, 1 for the first lens, 2 for the second, and so on, and the focal lengths of the lens. At the end of the above example, the focusing power of each lens is as follows. So in the end, we will have box 0, so it's 1 times And this is the first slot. So 1 times, and the focal length is 1. So 1 times 1 times 1 is 1. Then for the second one, it's still box 0, so it's still 1 times. It's the second slot, so 2 times. And then the focal length, which is 2, so that's 4. So the above example ends up with a total focusing power of 145. With the help of an over-enthusiastic reindeer in a hard hat, follow the initialization sequence. What is the focusing power of the resulting lens configuration? Wow, we got another easy problem today. That's fantastic.
Yeah, it seems relatively doable.
No, it's actually
Yeah.
kind of
Yeah.
kind of easy, I want to say. It's not that hard.
Yeah.
All right. So I will keep the documentation on the side because we will be referring to it often and we don't need this anymore.
I guess you could use sparse arrays for this as well.
No, I'm going to instantiate everything, and I will not need to extract this into a function because I will only need to hash things once, which is super convenient. Great. So my boxes are going to be an array, and for box index. Who am I kidding? Up to box index of 256. Box index plus boxes push an empty list. Then for const instruction. What do they call it? Each step. Okay, for each step of that, I will want to perform this step, and then later I will want to console log this situation. But let's start with this. So in here, I will need to check if I have an equals or a minus. I'm being taken a picture here because I have a cat on my side, which is cute. I will want to have the label and the instruction. So the label is my step match from the start of the string as many characters as you can. So A to Z plus. And my instruction
Would it not be simpler to split on a space and then you could destructure the output?
no, each of my steps it doesn't even have a space. Each of my steps is, for example, this.
Oh yeah, sorry, you're right. Doesn't have an equal always.
But what I can do, cute, thanks for saying that. Because what I can do is split on either an equals or a dash. And I can capture everything to the left and call it the label, and I can capture everything to the right and call it the focal. Focal, what do they call it?
Length?
Focal length? Thanks. Now, if my focal length is undefined, it means that I'm actually doing the minus operation.
Yeah, let's see if that works.
It does not like the syntax of my program. I have a syntactical problem in my program. what could the syntactical problem be?
Oh, you need to. You're writing Python. You've done too much Python recently.
Thanks. So this is indeed working, and I don't get null, I get an empty string.
Yeah. Okay.
Okay. And
which is falsy. Which I know you don't like.
No, at least that much I will do. I will do a number. I don't actually need that. I think this will do. But I will be computing this number later. But I will deal with that later.
Mm-hmm.
So, now that my parsing is done, I will need to perform the operations. So,
yes, need to hash it.
Yeah, I need to find my box index, which is the hash of my step.
Of your label, not your step.
Thank you. Then I need to check in my box index if there is, well, I guess I will case on what kind of operation I am doing. So if focal length is not empty, I will be doing this. Else, I will be doing that. If there is already a lens in the box with the same label, replace. So if my boxes at
oh, it says
box
replace.
index.
Okay. It says replace, so that means you can guarantee there'll never be more than one. I hadn't seen that part of it. That's good to know.
Ah, right.
I guess we need to search for it either way then.
Yeah, but I will look in the boxes into the right box, and I will check what is the index of a given lens such that, and I will need this index later, so I'll have here the lens index, such that my lens starts with, wait a second, no, my lens
Lens 0?
label
Are you going to store the array? Okay.
To
nice.
The label.
Nice.
And if my lens index is greater than -1, then there is already a lens in the box with the same label. Replace. So my boxes at box index at lens index is now going to be a data structure containing a label and the focal length, which I will turn into a number now for future convenience.
Very nice.
Otherwise, it's not in the box. So I will boxes, box index, push this thing. So I will call this my lens. And I will call this the existing lens index, and I will put this down.
Yeah.
All right. So this
Perfect.
covers the first clause. Now,
I guess you just move the existing lens index above the if, and above the first if. That way you can reuse it for the else.
Because what I want to do, if I am not replacing, is to remove. Good call. And I would argue that if I want to remove, I don't need to construct the lens, so that's all right. But what I want to do otherwise is to take my boxes, add box index like that. And is there a way to remove?
You'll need to check if you have an existing lens index though, by the way. But you'll just do splice, splice I0.
Yeah, I wanted to do it
I1.
in place though. Is there a way to remove elements from an array in place?
Yeah, splice.
Does splice change the existing array?
Yeah. Try 1, 1.
Ah, cool. So I want to splice at the lens index, and I know that the lens index may not exist. I'll check that. Else, essentially this.
Yeah.
Yeah.
Perfect.
Well, perfect. We'll see about that. I will take my... Are you fixing something for us?
No, I'm just making it more code golfy.
Okay. All right. By the end of this whole shenanigans, oh, we don't have a... no, that's silly. Do we have examples up to the... Do we have... OT7 is the last step. And after OT7... Oh, so that's right. Okay. So we should have RN1, focal length 1, CM2, and then in box 3 we should have we should have OT7, AB5, and PC6. Excellent. So now we need to compute the answer, which will be done in a single line by reducing over the boxes, starting with 0, getting the sum in a box, and adding to the sum. The box, reduce, starting at 0. No, starting at 1. No, starting at 0. And then there will be an inner sum, and the box will have lens.
Are you not going to run into issues with that reassignment of that variable?
I don't think so. I will add my box index. I will need the box index. Does reduce give me the index? Current index,
Probably,
yes.
Yeah.
Awesome. So this is my box index, and this is my lens index. So I'll add the box index plus 1 times the lens index plus 1 times the lens focal length. All right. 145, 145.
Oh, looking good.
That's the right answer. Woo-hoo.
Hey.
Day 15. We got this. They threw an easy one at us. Woohoo! Yay!
Lovely.
Awesome. Good job, everyone.
That was very
Good job,
satisfying, that
everyone.
last one.
I'm looking forward to seeing you again tomorrow, David. When is a good time for you?
In the morning, ideally, 10 a.m.
10 a.m. you say.
I can rearrange, obviously. What's most convenient for you tomorrow?
I think...
Because I'm more available, and you always ask me, so...
Checking the calendar. I would prefer in the evening. How about a good old Saturday night coding session?
Alrighty.
Who needs
What time?
party when we can have Advent of Code? Am I right?
You are, indeed.
All right. David, thank you very much for this.
What? But what does that mean? 10 p.m.
Yeah.
slot?
It could be a bit earlier if it works for you.
That's up to you.
But I would want to enjoy
Yeah, I
the
prefer
sun.
a little bit earlier. Yeah. Whatever sun there is.
Well, I have sun. Sorry. It won't last long, but I have it now. So yeah, thanks Nod Was One for joining us, and thank you, David, for coming up with this crazy idea to do this Advent of Code thing. I'm looking forward to seeing you again tomorrow. In the evening, is 10 p.m. the best for you, or can you do it earlier?
10 p.m. is great.
Okay then. So 10 p.m. tomorrow for day 16. Have a good one, everyone. Bye.
Bye.
Thank you for watching the stream, you know how great it has been. Or maybe it sucked, and I am glad that you stuck with me. And so we'll be back together for some more coding or talking or chilling. The next time I'll be streaming.